So the last session we discussed how to write the molecular formula of the compounds, and also if you know the molecular formula of the compounds, from that we will be able to write the skeletal equation and the balanced chemical equation. So we can discuss some examples how to do the balancing. Before start doing the balancing, you should remember always when you are trying to balance a chemical equation, first you should try to balance the atom which is greater in number. Always try to balance the atoms which are greater in number. If you are failed to do so, if you are not able to balance the atom which is greater in number in a particular reaction, next your trial should be like try to balance the atom which is least in number. So we can always try to balance from the greater number of atoms. That should be the more easier and convenient method. If you fail only, you should move to the next method. So we can write here, I am writing zinc react with copper sulfate. If you don't know the copper sulfate, you can write Cu and SO4. The molecular formula of the copper sulfate you don't know. If so, you should write Cu plus Cu and SO4, and copper valency is 2. I gave you copper valency is 2, and sulfate I gave you the valency, it is 2. You don't want to write the positive and negative along with this, because in the molecular formula we are not using any positive or negative sign. If you are having these numbers, please do remember the molecular formula is the simplest ratio only. So you have to make it simplest. For that purpose, here 2 and 2 can be cancelled and become 1 and 1. Then the number related to copper is given for sulfate. The number for sulfate you should provide it for copper. So you can write copper sulfate is Cu1SO41, CuSO4. Zinc react with copper sulfate. We will be getting zinc sulfate and copper. Again we can try to write zinc sulfate. For that purpose I am writing zinc and sulfate will be SO4, and we discussed zinc valency is 2 and sulfate valency is 2. If so, 2 and 2 can be again further cancelled, 1 and 1. Again the molecular formula will be same. What is that? Zinc sulfate plus copper. This is the chemical equation. We don't know whether it is balanced or not, but we can say this is the skeletal equation because we represented this chemical reaction in terms of the molecular formula of or the symbols of each and every species present in it. So zinc is Zn and copper sulfate, zinc sulfate plus copper, we wrote the equation. Now we can try to convert this one into a balanced chemical equation. For that purpose I told you first you should try to balance the species which is greater in number. One more point you should remember when you are balancing. When a polyatomic ion, that means the radicals are present in the reactant side and in the product side, you don't want to split them into different atoms and try to balance. If the radicals are present in the reactant side and in the product side same, that means sulfate is present in the reactant side, same way sulfate is present in the product side. You are not supposed to split the sulfate into sulfur and oxygen. Here you can take sulfate as a whole species. So here I told you the first step is to balance the number, the atoms which is greater in number. So here the greater in number nothing but sulfate as a whole. If you are considering SO4 in that oxygen is there, I told you don't try to split sulfur and oxygen because in the product side also sulfate is present. So sulfate is 1 and 1. Why? Because here this is 1, here also the number 1. So sulfate 1 and here also sulfate 1. So as it is sulfate is balanced, we can check zinc. Zinc is 1, here also zinc is 1. Here it is copper. Copper is 1. Here also copper is 1. So we can say the skeletal equation is a balanced equation. Already the skeletal equation what we wrote, that is a balanced chemical equation. Now the second example I am writing magnesium react with hydrochloric acid. Hydrochloric acid is HCl. If you don't know, again I told you how to try. Hydrogen and chlorine. Hydrogen is in first group, so valency +1. Chlorine is in 17th group, valency -1. So 1 and 1. Cross over the valency, so HCl. And next one, magnesium react with hydrochloric acid. We will be getting magnesium chloride. So I don't know the formula of magnesium chloride, so I am trying to write magnesium and chlorine, Mg and Cl. Then magnesium is in group 2, so valency 2. I gave you in the periodic table, it is there. And chlorine is in group 17, so valency 1. So you can cross over the valencies. So the number 2 should be provided for chlorine, the number 1 should be provided for magnesium. So the formula of magnesium chloride is Mg1 and Cl2. So MgCl2. So magnesium will react with a hydrochloric acid, you are getting magnesium chloride and hydrogen gas. So hydrogen I am writing H, but in the previous unit we discussed there are certain elements which can exist as diatomic only. Among that, hydrogen is a diatomic. So you can write hydrogen is existing as H2. Fine. This is a skeletal equation because a chemical reaction we wrote in terms of symbols and molecular formula of all the species. So magnesium react with the hydrochloric acid, magnesium chloride and hydrogen gas. We wrote that. Now we have to follow, or we should try to balance this chemical equation. For that, first of all, you should check whether it is balanced or unbalanced. Magnesium 1, but hydrogen 2, 1, hydrogen 2, chlorine 1, chlorine 2. So it is not a balanced chemical equation. So how to balance the chemical equation? I told you, for balancing this chemical equation, first we should try to balance the atom which is greater in number. When you will see this, here everything is reactant side, everything is 1, 1, 1 only. But in the product side, chlorine is greater in number. Similarly, hydrogen also greater in number. So either chlorine or hydrogen you can try to balance. So I am taking chlorine first. So chlorine, how many are there? There are 2 chlorine over here. So I am trying to balance that. For that I am putting a 2 here. Is it correct? No, because already I told you we are not supposed to change the molecular formula of the compound. If you want to balance a chemical equation, the numbers what you are planning to provide, that should be before its symbol. So what is the symbol of hydrochloric acid? HCl only. So before its symbol we should write the number. So it will be HCl like this. So 2 HCl. So when you are checking this, chlorine is 2 here, chlorine is 2 here, chlorine is balanced. What is the next one? Hydrogen. Hydrogen, if you will see, here there are 2 hydrogen, and in this case also there is 2 hydrogen. So hydrogen is balanced, chlorine also balanced. As hydrogen and chlorine are balanced, we have to check where the next element is magnesium. So magnesium is 1, here also magnesium is 1. So everything is balanced. This is a balanced chemical equation. So a skeletal equation we converted into a balanced equation. Same way, let us consider, I am writing another reaction example. Example number 3. Example number 3. Here I am writing a balanced chemical equation, a chemical reaction like this. Methane on incomplete combustion, we will get carbon monoxide and water. Carbon monoxide and water. Methane formula is CH4. So you may be wondering from where methane is CH4, the molecular formula. In carbon and its compounds chapter, how methane formula we can write CH4 we will discuss later. So CH4, methane, on combustion. Combustion means burning with excess of oxygen. We will be getting carbon monoxide. I told you incomplete combustion will result carbon monoxide and water. So I am writing all these things. Carbon monoxide, water, everything I wrote. Now we should check whether it is, this is the skeletal equation because according to the symbols and molecular formula we represented the reaction. What is the reaction? Methane on incomplete combustion will produce carbon monoxide and water. Now we can try to balance. What is the rule we should use for balancing? I told you, try to balance the atom which is greater in number. When you will see here hydrogen is 4. Check all other species, greater number will be hydrogen only. So as hydrogen is 4, I should try to balance the hydrogen first. If I fail, then only I will be moved to the element which is smaller in number. Here hydrogen is 4. In the product side, hydrogen is 2 only. So I am not supposed to change it as 4 here. I told you it is not possible. If you want to balance, you can put a number 2 over here. So it will be 2H2O. So what is balanced? Hydrogen is balanced in both the sides. As hydrogen is balanced, you should check along with hydrogen carbon is present. Carbon is 1 in number. Here also carbon is 1 in number. So carbon is balanced. Now the next one is what? Oxygen. So oxygen here, oxygen number is 1 in this side and 2 in the other. So total of 3 oxygen. Here oxygen is 2. In this case, particular cases where in any one of the reactant or product side, a particular element is even in one side and the same element is odd number in the other side. Mainly this is coming, most of the cases oxygen. In such cases, what you should do is, the odd number what you are getting, that divided with 2 you should multiply in the product side. So here it will be, I am putting 3 by 2. 3 by 2. Why I put divided by 2? Because 3 by 2 into, there are 2 oxygen over here. So 3 by 2 into 2. So 3 by 2 into 2 will be what? It will be 3 only. So in one side if it is odd number and the other side if it is even number. In the even number side, what is the odd number you are getting in the other side? You should multiply that number by 2 in the other side. So I am putting 3 by 2. 3 by 2 means 3 by 2 into 2 is here. So it will be total 3. So 3 and 3, it is balanced. But whenever you are balancing, we cannot keep a fractional number at all. If you want to remove that fraction, what we should do, if you are multiplying in the entire equation with 2, so we can put, I am putting 2 here, I am putting a 2 here, I am putting a 2 here. Here also I am multiplying with 2. So what will happen? This 2 and this 2 will cancel. So it becomes whole number only. So I am modifying this expression as, or equation as, 2CH4 plus 3O2 gives 2CO plus 4H2O. I hope you understood. So now we can check the atoms. 2 carbon, here are 2 carbons. Hydrogen will be 4 2s are 8. 4 2s are 8 hydrogen. So here 4 2s are 8 hydrogen. Yes, balanced. Carbon and hydrogen balanced. Carbon is balanced, hydrogen is balanced. Now oxygen is 3 2s are 6. 6 oxygen here. Here 2 plus 4. So it will be 6. Everything is balanced. So this is the way we can balance a chemical equation.